Hello and welcome back to science. I hope you had fun yesterday. If you don't, I filmed these on weekends, so I don't know if you were able to be on Brain Pop yesterday or if you had to do the skater lab. Either way, I hope it was a good time learning more about kinetic energy, energy of motion, and potential energy. Now, energy cannot be made, cannot be destroyed. We are not God. That is a God thing. However, energy can transform. So we talked about how it could be potential or kinetic energy. Potential can transfer to kinetic energy, kinetic to potential. We're going to finish talking about this section about how energy can change in other forms too. Your book says, I'm on page 229. No, I'm not. I'm on page 230. Page 230. Silly Mrs. Bulwark. Silly Mrs. Bulwark. So, your book says consider an electrical device, such as a photocopier. The electrical energy is changed to light energy and mechanical energy. The photocopier also changes electrical energy into sound energy when it beeps. Energy is not lost, it's just transferred. Your book gives us a couple examples of energy being transferred. The first is electrical energy to mechanical energy. Mechanical energy, we talked about that before, the sum of the kinetic and potential. But they give us an example of mechanical energy is the energy an object has due to its position or motion. A bicycle in motion and a whirling blade of a fan have mechanical energy. Electrical energy can be changed into mechanical energy through a washing machine. So I'm able to press a bunch of buttons and start the electrical part of the washing machine, and that takes the mechanical part of moving the clothes around, stirring the clothes around to make sure everything's getting cleaned. We also have mechanical energy creating different types of electrical energy for us with things like hydroelectric dams, wind generators, things like that that are spinning turbines so that we can have electricity. Identify. What other type of energy is electrical energy transformed into in a washing machine? What do you think? Heat's usually with a dryer, not a washing machine. What about kinetic energy? Kinetic energy. Energy of motion, so kinetic energy. All right. Chemical energy to light energy. It says a lightning bug uses light to attract its mates or prey. The lightning bug has chemicals in its abdomen. These chemicals have stored potential energy. The chemical potential energy changes to light energy. Chemical energy is energy of the electrons that form bonds between atoms and molecules. Bonds form when electrons are shared by atoms, or when electrons are transferred from one atom to another. When more electrons are involved in a bond, more chemical energy is in the bond. This insect produces a small amount of light energy. I can tell you something about this using big fancy words. When we're talking about electrons giving off energy, they actually can release light. We call this the photoelectric effect because electrons are very similar to light particles. They are wave-like, they're so tiny. They're like a wave and they're like a light wave. So when electrons are involved, you can increase chemical energy, and giving off that energy can have it change to light. Question 9 says, name. what is the device that changes chemical energy into light energy? Kind of like something that you might have in the dark. There's a lightning bug right here, but we would have a flashlight. A flashlight takes chemical energy and turns it into light energy. Finally, we have magnetic energy to kinetic energy. It says magnetism is a force that pushes and pulls on other objects. The magnetic force is greatest at the magnet's poles. The poles of a magnet are at the two ends. Every magnet has a north pole and a south pole. Magnets pull on objects made of iron, cobalt, nickel, and gadolinium. Magnets also exert forces on other magnets. An object being pulled by a magnet will gain more or less kinetic energy, depending on how far it is from a magnet. The object has potential energy once it's been pulled towards or pushed away from the magnet. So, an object being pulled by a magnet is going to gain more or less kinetic energy or energy of movement depending on how close or far it is from the magnet. Once it has been pulled towards after that motion or pushed away after that motion, it is now potential energy. It says on question 10, infer in the picture to the right, the paper clips are pulled to the magnet. Which form of energy do they have? Well, I'll ask you this question. Are those paper clips moving? No? That should help you find an answer. Are they moving? No. Okay, well, since they're not moving, what type of energy is that? That's right, potential energy. Good. So potential energy. Now, let's answer questions 11 and 12. 11 says, which has more kinetic energy? A 50-gram basketball resting on a chair or a 75-gram basketball resting on the floor? Which has more kinetic energy? What do you think? Remember what kinetic energy is. All right, well, this is a trick question. Kinetic energy, and the basketball is sitting on a chair. And another basketball is on the floor. They're not moving. So they have the same amount of kinetic energy because all of them have no kinetic energy. The basketball isn't moving, no kinetic energy. This basketball, it's on the floor, it's not moving, no kinetic energy. I hope when you're doing your science homework, I know 6th grade you love basketball. I hope that your basketballs have no kinetic energy while you're doing homework for science. All right, let's look at 12. A squirrel drops an acorn from a tree. How does the potential energy of the acorn compare to its kinetic energy just before the acorn hits the ground? So a squirrel drops an acorn from a tree. How does the potential energy of the acorn compare to its kinetic energy right before it hits the ground? Remember what makes different types of potential energy. I've talked about it yesterday, but we have something called gravitational potential energy. Gravitational potential energy increases the higher you are from the ground. So, this acorn is right above the ground. That tells me does not have a lot of potential energy. So this acorn has low potential energy. What about kinetic energy? Yes, it is currently falling. It is falling, and so it would have a lot of kinetic energy, especially since it's been building up speed as it has been falling. So, not a lot of potential energy because it's so close to the ground. And it is moving or falling, so it has a lot of kinetic energy. Good. Tomorrow you're going to be working on a homework assignment for science class, and on Friday you're going to be playing a game. Now, Mrs. Bulwark was able to beat this game in 5 levels, and she thinks that you can do it too. It has questions that we might have not covered in class, but you can easily figure out what the answer might be in this game. I hope you enjoy it, and I hope you've enjoyed learning about energy, and I will talk to you later.